Determine all intervals of increasing trend or decreasing trend and determine the coordinates of all maxima, minima, plateaus, or cliffs for the function f of x equals x plus 5 divided by x squared minus 9. The first thing to do is find the domain. F of x equals x plus 5 divided by x squared minus 9 is a quotient of two expressions. They're both polynomials. The domain will be all reals for both of them, but there is a denominator here, and the domain requires that the denominator cannot equal 0. So x squared minus 9 does not equal 0. We can difference of squares factor the x squared minus 9, which is x plus 3 and x minus 3, does not equal 0, and therefore x cannot equal negative 3, and x cannot equal positive 3. The domain will be all real numbers, but negative 3 and positive 3. The domain begins at negative infinity up to negative 3. It doesn't include negative 3, round bracket, and then starts again at negative 3. Again, doesn't include it, round bracket, up to positive 3, does not include it, round bracket, and starts up again at positive 3 and goes to positive infinity. That domain will be all real numbers except for negative 3 and positive 3. They've been removed by having round brackets. The next thing to do is find all critical numbers. We will take the first derivative. F of x is a quotient of two expressions, so the first derivative will make use of the quotient rule. The derivative of the numerator, which will be a 1, times the denominator left alone, x squared minus 9, minus the numerator left alone, x plus 5, times the derivative of the denominator, 2x, all over the denominator squared. We can distribute the 1 in the first expression in the numerator. That will give x squared minus 9. And we can distribute the negative in the 2x in the second expression in the numerator. That will give a negative 2x squared and a negative 10x. All over the denominator that we'll leave alone. We can combine like terms together in the numerator. The x squared and the minus 2x squared can combine together to become minus x squared. We have a minus 10x, and we have a minus 9. We want to fully factor the first derivative. There is a common factor of a minus in the numerator, which will factor out, leaving a positive x squared, a positive 10x, and a positive 9. And in the denominator, we have a difference of squares, which can factor to an x plus 3 and an x minus 3. And the entire thing is squared. In the numerator, we have a trinomial quadratic, which can factor to x and x. We need two numbers that multiply to be a positive 9 and add to be a positive 10. Sounds like positive 9 and positive 1 will take care of that. In the denominator, we have it factored and the entire thing squared. Each of those factors can be squared individually. X plus 3 squared and x minus 3 squared. So we have the first derivative as a single fraction. All powers are positive. It's fully factored. We can now set the numerator equal to 0 and the denominator equal to 0 and solve for all x's. Starting with the numerator, negative of x plus 9 times x plus 1 equals 0. We can divide both sides by the negative and it just cancels out. But this is already factored, so we can see that x will equal a negative 9 and x will equal a negative 1. Now working with the denominator, we have an x plus 3 squared and an x minus 3 squared equals to 0, which is fully factored. We have a factor of x plus 3 equaling to 0, so that tells us that x can equal a negative 3, and an x minus 3, that can tell us that x equals positive 3. The squared power in each of them just tells you have two factors, but they both are of the same type. We now check and see which of these are in the domain. The domain is all real numbers except for negative 3 and positive 3. These are real numbers. They're not negative 3 or positive 3. We keep them both. These ones are negative 3 and positive 3, which is not in the domain. We cross them out. So we have two critical numbers here. We can now draw a domain line, a line representing the domain. It starts at negative infinity and goes all the way to positive infinity, meaning it has no left end or right end. But it's already split due to vertical asymptotes at negative 3 and positive 3. They made the denominator 0 for the original function. They are vertical asymptotes. There's one of them at negative 3, and there's one of them at positive 3. We can indicate these by a dashed line to remind us that they are not critical numbers, they're vertical asymptotes. The domain is already split into 3 intervals. We can put the critical numbers on here, which further split these into more intervals. So we actually have 5 different intervals. We can pick a test value in each of these intervals. The first interval is negative infinity to negative 9. We can pick negative 10 in there. And then we have the negative 9 to negative 3. We can pick negative 5 in there. The negative 3 to negative 1, we can pick negative 2 in there. Negative 1 to positive 3, we can pick 0 in there. And then positive 3 to positive infinity, we can pick 10 in there. We can test the trend in each of these intervals by plugging the corresponding test value into the first derivative. We don't care about the value of the derivative, just whether it is positive or negative. And therefore, the best version to plug into is the fully factored version. A couple things about this. The denominator, each of the factors are squared, and squared factors always become positive numbers. That entire denominator is a positive number and will not influence the sign of the first derivative. In the numerator, the factors are to the first power, so they can be positive or negative, but we don't want to forget about this negative that's here. It is part of the result. So only the numerator will matter. Starting with plugging in a negative 10, negative 10 plus 9 is a negative. Negative 10 plus 1 is a negative. We have 3 negatives. 3 negatives multiplying gives a negative. We have a negative first derivative. This corresponds to a decreasing trend. Plugging negative 5 into the part of the first derivative that matters, negative 5 plus 9 is positive. Negative 5 plus 1 is negative. Negative times positive times negative is positive. We have a positive first derivative that corresponds to an increasing trend. Plugging negative 2 into the part of the first derivative that matters, we have a negative 2 plus 9 is a positive. Negative 2 plus 1 is a negative. Negative times negative is a positive. We have a positive first derivative. That'll be a corresponding to a trend increasing. Plugging in 0 to the part of the first derivative that matters. 0 plus 9 is positive. 0 plus 1 is positive. Negative times positive is negative. We have a negative first derivative. This corresponds to a trend decreasing. And then we can plug positive 10 into the part of the first derivative that matters. 10 plus 9 is positive. 10 plus 1 is positive. Negative times positive is negative. We have a negative first derivative. And this corresponds to a trend decreasing. So we have a decreasing trend happening from negative infinity up to negative 9, union, because it's happening again, from negative 1 to 3, union, because it's happening yet again from 3 to positive infinity. We have an increasing trend happening from negative 9 to negative 3, union because it's happening again from -3 to -1. Right at the critical number of -9, we have a trend change of decreasing to increasing. And that makes -9 a relative min. So we have a relative min and an x-coordinate of -9. We can find the corresponding y-coordinate by plugging the -9 in for x into the original function. So y will be f of -9. Which will be -9 plus 5 divided by -9 squared minus 9. -9 plus 5 is a -4. -9 squared is an 81, and then minus 9. So this will be a -4 over 81 minus 9 is a 72. 72 is divisible by 4. And a 4 is divisible by 4, so that'll become a 1 and 18. So we have a -1 over 18. That will be the corresponding y-coordinate for the relative minimum. X equals -3 and x equals +3 here. These are vertical asymptotes. They are not critical numbers. But we do have a critical number at -1, and we have a trend change of increasing to decreasing. That means that there will be a relative maximum, the x-coordinate of -1. We can find the corresponding y-coordinate by plugging the x-coordinate into the original function. So y will be f of -1, which is -1 plus 5, divided by -1 squared minus 9. -1 plus 5 is a 4. -1 squared is a 1 minus 9, which is 4 over 1 minus 9 is a -8. Each of these are reducible by 4. Positive over negative is negative. 4 over 4 is a 1. 8 over 4 is a 2. So it comes out to a -1/2. So we have 3 intervals of decrease, 2 intervals of increase. We have a relative min at -9, -1 over 18, and a relative max at -1, -1/2.